Okay, so today we're gonna try to read visual instruction tuning. So if you're not familiar with it, let me actually share the demo. Let me buff every time I need to change it. Such a bummer. Change window, and basically you get an image and you can just ask a query and the model will look at the image and reply to you. So let's see in this example here. Let's see the usual. Okay, we have an image of a guy doing some weird stuff behind a car. His iron clothes while standing on the back of a moving car. Okay, well, let me also try with a meme. Let's see. Okay, so this is a meme saying play video games with the boys, me, and then my girlfriend. And then I guess I can just what is in this image? I guess should that work? Okay. Come on. The image features a comic strip with a man and a woman where the man is holding a video game controller. Okay, here we have hallucination, right? Because it's saying the man is holding a video game controller, which is not true, but here you have video games, so probably it's just hallucinating that. Okay. I mean, it's quite wild that with the first example, we got something that is not quite good, right? That's interesting, but maybe
This is not hallucination.
yeah, because here is so
This is
it depends on what is your definition of hallucination. So to me, it's just doing something that is not true, right? That
it's
you know,
look like the model is highly perplexed, confused. So
yeah. I mean, here
okay,
it's
okay.
just saying where the man is holding a video game controller, which I guess it makes sense because probably it's getting some sort of guide from the fact that we have video games here, and but I guess maybe it was not trained on cartoonish images. I don't know. So let's try to have a look at the paper maybe, and we will see the data set. Let me rechange this one and then reshare. Okay, change window. Let's see. Okay, paper. So visual instruction tuning. And this is from some time ago, though. Why are people talking about this now? Maybe they have just released the code. I don't know. Well,
GPT-4.
yeah.
GPT-4 is bringing attention toward visual instruction tuning because visual instruction has this thing capability which GPT-4 is also reflecting. However, there is some speculation regarding the perception of any object in the model that how the like this is also almost equivalent to something like it can chat means basically you can chat about image. So let's see what is further.
Okay, so instruction tuning large language models using machine-generated instruction following data has improved zero-shot capabilities on new tasks, but the idea is less explored in the multimodal field. This paper will present the first attempt to use language-only GPT-4 to generate multimodal language image instruction following data. By instruction tuning on such generated data, we introduced LLaVA, a large language and visual assistant, an end-to-end trained large multimodal model that connects a vision encoder and an LLM for general purpose visual and language understanding. Our early experiments show that LLaVA demonstrates impressive multimodal chat abilities, sometimes exhibiting the behavior of multimodal GPT-4 on unseen images instruction, and yields an 81.1% relative score compared with GPT-4 on a synthetic multimodal instruction following dataset. When fine-tuned on Sans Q&A, the synergy of LLaVA and GPT-4 achieves as a new state-of-the-art accuracy of 92.53%. We make GPT-4 generated visual instruction tuning data, our model, and code base publicly available. Okay, makes sense. So they somehow created a dataset with GPT-4. Should we skip the introduction as always, or yeah? So let's maybe here in this paper we present visual instruction tuning, the first attempt to extend instruction tuning to the multimodal space. Okay, so here the novelty is that we have instruction tuning, which paves the way towards building a general purpose visual assistant. In particular, our paper makes the following contribution: multimodal instruction following data. How keen challenge in the lack of visual language instruction following data? One key, okay, so sorry, that was the full sentence. We present a data reformation perspective and pipeline to convert image text pairs into the appropriate instruction following format using ChatGPT/GPT-4. Large multimodal models will develop a large multimodal LMMM, okay, so by connecting the open set visual encoder of CLIP with the language decoder of LLaVA, and fine-tune them end-to-end on our generated instruction visual language data. Our empirical studies validates the effectiveness of using generated data for LMM instruction tuning and suggests practical tips for building a general purpose instruction following visual agent. With GPT-4, we achieved a state-of-the-art performance on Sales Q&A multimodal reasoning dataset, and it's open source. Okay, so here the focus seems to be on the fact that we have instruction following. So not just, I don't know. So what's the big deal with instruction following in the multimodal sphere? Related word, multimodal instruction following agents. Computer vision, existing work that build instruction following agents can be broadly categorized into two classes: end-to-end trained models, which are separately explored in each specific research topic. For example, the vision language navigation task and habitat requires the embodying a agent to follow natural language instruction and take sequence of actions to complete goals in visual environments. Okay, in other editing domain, given an input image and a written instruction that tells the agent what to do, instruction pix to pix, edit image by following human interaction. Okay, so a set of models that are very task specific and they need to understand an image and follow user instructions. Or number two, assistant that coordinates various models with long chains, LLMs such Visual, ChatGPT, GPT, MM, while sharing the same North starting building instruction following agent, we focus on developing end-to-end trained multimodal. Okay, so Visual, ChatGPT, etc. And basically, I mean, I guess that this whole set of models, they are multimodal in the sense that basically they have a model to understand the image and convert it to text, and then the language model basically read the text or whatever was in the image, which is not very, yeah. I'd say it's more like a trick than the proper way, in my opinion. Instruction tuning. We should know what instruction tuning is in the natural language processes NLP community. To enable large language models such as GPT-3, blah 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 to follow natural language instruction and complete real-world tasks. Researchers have explored methods for large language models instruction tuning, leading to instruction tune counterparts such as InstructGPT and ChatGPT, Flan, blah blah blah. Yeah. It turns out this simple approach can effectively improve the zero and few-shot generalization ability of large language models. It is thus natural to borrow the idea from NLP to computer vision. Flamingo can be viewed as the GPT-3 moment in the multimodal domain. So yeah, true. Due its strong performance, zero-shot task transfer, and in-context learning. Other large multimodal models trained on image text pair include the Flip2 and Froma G and Cosmos 1. There is Cosmos 2 now. Palm-E is a large multimodal model that embodies AI. Okay, for embodiment AI. Yeah, okay. Based on the recent best open source LLaVA, Flamingo LLaMA adapter are open source adapters that enable LLaMA to use image inputs, paving a way to build the open source multimodal large language models. While promising task transfer generalization performance is presented, these models are not explicitly instruction tuning with vision language instruction data. Yeah, like usually the way you do that, there are multiple ways. I think we have seen one or two ways in other session. It's basically you tokenize the image and you put that in the input as well of the language models, like with Flip2. The issue though is that usually all the dataset that this model uses, image and text pair, they suck. So they really suck. Thus, the model will suck in the end. Yeah. So let's see. In this paper, we aim to fill the gap and study its effectiveness. To clarify, visual instruction tuning is different from visual prompt tuning. The former aims to improve the model's instruction following abilities, while the latter aims to improve the parameter efficiency in model's adaptation. Okay. Visual prompt tuning. Yeah, well, yeah, I guess. So let's see how they create the dataset. I'm getting some deja vu here to some degree. I think I have already read this paper.
No, there exists a similar paper like this, which is
You know why it was all over.
template world.
I'm sorry. Sorry, Mr. Robot.
They said it's a template. It's a template being copied from other paper. It's just a template. So that's why you must have seen this type of
No. I know
representation.
why. So this is from spring of this year, but they released the 1.5 version, which is so much better. So this is why it was all over the place, because they released a new version, which is better. But the paper is from 6 months ago, whatever. Okay, so that's why. Now I remember. Okay, so let's see, because I guess this is the secret ingredient, right? So the community has witnessed a surge in the amount of public multimodal data, such as image text pairs, ranging from CC to Lion. And Lion is the one used for clip and guess for stable diffusion as well to some degree. However, when it comes to multimodal instruction following data, the environment amount is limited, partially because the process is time consuming and less well defined when human crowd scoring is considered. Inspired by the success of recent GPT models in text annotation tasks, we propose to leverage ChatGPT, GPT-4 for multimodal instruction following data collection based on the widely existing image pair data. For an image XV and its caption XC, it is natural to create a set of questions XQ with the intent to instruct the assistants to describe the image content. We prompt GPT-4 and curate such a question list in table 8 in the appendix. So let's have a look. The list of instructions for brief image description. Describe the image concisely. Provide a brief description of the input image. Offer a concise explanation. Okay. Create a compact narrative representing. Okay. So a set of questions describing the images. Damn. Okay. Therefore, a simple way to expand an image text pair to its instruction following version is human. Here we have a question, the image. Okay, so so the human is asking a question about the image. Stop, assistance, and we have the caption. Okay, yeah. So basically, you know, the questions are made in such a way that you need to reply with the caption, basically. I don't know if this makes sense to you. So they want to create a data set to do instruction tuning, right? So they need to have a query for the user and a reply, and a correct reply for the assistants. The correct reply is the captions, which they have, and the question is just, it's one of these, basically, paired with the image. Too cheap to construct. This simple expanded version lacks diversity and in-depth reasoning in both the instruction and responses. To mitigate these issues, we leverage language-only GPT-4 or ChatGPT as the strong teacher. Both accepts only text as input to create instruction following data involving visual content. Specifically, in order to encode an image into its visual features to prompt a text-only GPT, we use two types of symbolic representation. Captions, typically they describe the visual scenes from various perspectives. Bounding boxes usually localize the object in the scenes, and each box encodes the object concept and its spatial location. One example is shown in the top block of table 1. This is content text 1. This is the caption. Group of people standing, yeah, some people and a black man. Then they have the boxes. Okay, so they incorporate that to the prompt as well. The symbolic representation allow us to encode the image as a large language model recognizable sequence. We use Coco images and generate 3 types of instruction following data. One example per type is shown at the bottom of block of table 1. So they have 3 types of instruction, like question, what is the type of clickable which is this image, the answer, the image feature, a black spot, blah blah, what is the clickable Parker. Okay, so they generate them, and detailed description. Okay, long the description, complex reasoning. Question, what challenge do these people face? In the image, a group of people is standing outside a black SUV in a parking area surrounded by various pieces of luggage, blah blah blah. So basically, I guess these are all generated, right, by using the caption and the bounding boxes. Okay. One example per type is shown, yeah. For each type, first manually design a few examples. We first manually design a few examples. They are the only human annotation we have during data collection and are used as seed example in the context learning to query GPT-4. Conversation. We design a conversation between the assistant and a person asking questions about this photo. The answers are in a tone as if the assistant is seeing the image and answering the question. A diverse set of questions are asked about the visual content of the image, including the object type, blah blah blah. See table 10 for a detailed prompt. Let's see. So this is very good paper, giving you all the information. The prompt used to generate image-based conversation from ChatGPT and GPT-4. We add the messages, system, you are an AI visual system, you are seeing a single image. What you see are providing 5 sentences describing the same image you're looking at. Answer or question as you are seeing the image. Design a conversation between you and a person asking about this photo. The answer should be tone that visually assistant see the image and that's me the question. Ask them as questions. Okay. Yeah. So basically, they are include question asking about the visual content of the image, including the object types, counting the object. All include questions that have definitive answers. One can see the content of the image. Okay. So basically, they use these to generate the conversation that they will use to fine tune, which makes sense. Makes very sense. Come on. Okay, now I want to know the architecture. So let's see, we collect 188k, maybe we can look at the data set some point, and blah blah blah, etc etc. So let's see the architecture here. The primary goal is to effectively leverage the capability of both the pre-trained large language model and visual model. The network architecture, typo, illustration figure 1. We choose LLaVA. Yeah, a good project would basically be to retrain this with the new Mistral Orca model and see what happens. We choose LLaVA as our large language models, f theta, parameterized by theta, as its effectiveness has been demonstrated in several open source language only structure. Okay, so we have our LLaVA, right? And what we do, we get our image, visual encoder, which I think it's clip, and then I guess we need to do a projection to the mismatch in dimension, and then I guess we concatenate them with the tokens of what was of the text. For an input image, we consider the pre-trained clip visual encoder, the big one, which provide the visual features ZV, equal G, G is a visual encoder. The grid feature before and after the last transformer layer are considered in our experiments. The grid features, okay. I don't know why before, I don't know. We consider a simple layer to connect image features into the word embedding space. Specifically, we apply a trainable, so they just train the projection, the weight of the projection into the language embedding tokens HQ, which have the same dimensionality of the word embedded space in the language model. So HV, which are the projected image features, image tokens, are just a trainable projection used on the output of clip. Thus we have a sequence of visual tokens HV. Note that our simple projection scheme is lightweight and cost effective, which allow us to iterate data-centric experiment quickly. More sophisticated but expensive schemes to connect the image and language representation can also be considered, such as gated cross-attention in Flamingo and Q-forming in Blip2. I think we read Blip2, and Q-former was very clever. Or other visual encoders such as SAM that provide object level features. I don't know why you would use SAM. We'll leave exploring possibility more effective and sophisticated architecture designed for LLaVA as future work. Okay, so what you get here, the language instructions. So the language instruction will be the XQ. The XQ will be the full thing, right? So just the generated conversation, I guess, right? So the input sequence used to train the model. Only 2 conversation tones are illustrated here. In practice, the number of tones varies based on the instruction following data. In a current implementation, X system message equal a chat between a curious human and then artificial intelligence systems. Okay. Human, structure 1. Okay, so this is the generated chat, and this is the system prompt. The model is trying to predict the assistant answer and where to stop, and thus only grid sequence tokens are used to compute the loss in the autoregressive model. Okay. Okay, makes sense. Very clever. Um, any doubt so far? I don't know.
Nah,
So
let's move
essentially,
forward.
Oh, Didi, please.
yeah, no, I'm just trying to summarize this. So they train it with this whole, okay, they use Llama architecture to do the whole uh, generating questions, and then they have a visual transformer that responds, and then in the training, they essentially the responses are the captions, and then they train on that, and then they fine tune using some other specific prompts, something like that.
Yeah. So
Yeah.
like they generate this conversation, like this
Hmm.
multi-step conversation using GPT-4, giving the caption and the bounding boxes of each image, and then basically they just train it to predict given some image features, and
Okay.
like the tokens from here, so they just train to predict the stop token and the answer, I guess.
Mm.
So yeah, it seems very simple, actually. It's very
Yeah.
simple. uh, and training,
Yeah.
so
Nicely done.
yeah, quite smart. I don't know how much they pay to GPT-4, but this is from Microsoft. So I guess that they had a partnership back in the days, even today.
Yeah. Yeah. It makes me think what other modalities we can just use this kind of thing, like ultraviolet or whatever else, I guess. Yeah.
Yeah, like to me, the issue here is that basically you are, uh, yeah, I mean, still, I guess, because I mean, you're using a language model though, right? And you put images inside it, so I guess there must be. So how can you, how can you fight when the model does not really understand what is inside the image?
Right.
Yeah, I don't know, and too stupid for that.
Yeah. Yeah. No, I guess the limit is like, okay, well, how much do language models really know? You know?
Yeah, for
Yeah.
sure. And like maybe, can I, like, so they say that they use Coco, which is shitty as data set. So yeah, I mean that
That's
yeah. So here I guess, I mean, they are showing us that it kind of works, even if with this just using Coco basically. Which is pretty amazing. So I kind of wonder, so what if you really take a data set that is very good and you do this, maybe on Llama 2? Yeah, that would be
yeah,
pretty
definitely.
pretty wild, I guess. Uh, so training, so let's see training. So for each image X, okay, so here, yeah, we generate our multi-tone conversation data, X blah, blah, blah. So query query assistant at each time step, where T is the total number of tones, okay. We organize them as a sequence by treating all answer as the assistant's response, okay. So all answers, yeah. um, and the instruction xt instruct at the turn as what the hell is xt instruct? Randomly choose, okay, so randomly choose a pair of query an image or image and query, if this is the first term. Yeah, so like, you know, at the beginning, I guess you need to have an image, right, as well, and then you just pick another query. This leads to the unified format for the multi-model instruction following sequence illustrated in table 2. We perform instruction tuning of the large language model on the prediction tokens using its original autoregressive training objective. Specifically, for a sequence of length L, we compute the probability of generating target answer XA by, I guess this is the normal loss, I guess. Let's see where theta is the trainable parameter. X instructs, yeah, this one, less than I, and X A, so the answer by the assistant, right, minus are the answer and answer tokens in all terms before the current prediction token xi respectively. And they have included the image as well. Okay, I guess it makes sense here. We just want to predict the next token, basically, right? Nothing weird. And for Llama model training, we consider two-stage instruction tuning. Pre-train for future alignment. I know that Mr. Robot really likes the word alignment. To strike a balance between concept coverage and training efficiency, we filter C. Oh, okay, so they're not using Coco. They have a lot of. No, wait. Yeah, they have a lot of stuff. Okay, blah 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 blah. So they create a data set from this data set here. Example can be treated as a single turn conversation. To construct an input X construction 2 for an image XV and a question XQ. In a question XQ on table rate is randomly samp. Okay, so like here they just pre-training on a pair, you know, image, question, and answer, right? They didn't do the tuning, looks like. Okay, yeah, so they just do one turn of the conversation. Then they do the fine-tuning until end. We only keep the visual encoder weights frozen and continue to update both the pre-trained weights of the projection layer and large language model in LLaVA. Okay. Multimodal chatbot. We develop a chatbot by fine-tuning on the 188Q unique language image instruction following data. Yeah, that we know. Then they also have a science Q&A. We study our method of the science Q&A benchmark. The first large-scale multimodal science question dataset that annotates the answer with detail. I don't know about that, so let me Google that. So let's see. I'm gonna share, change window. So let's see this one. So can I see the data set about science Q&A? You have a question, we have options, we have context, we have the answer, we have the because, and we have the explanation. Okay, so yeah, it looks like a data set with, you know, a lot of context stuff, right? Okay, Okay, that's very cool. But are there any images though? Like, do they have images in the data set? I don't know. Because from here, I don't see any images. Like, so multimodal. So on the paper, they say it's multimodal. Here, I don't see the image. I don't see the images.
Maybe in the download section above.
Download. So they have GitHub. They have
In the
GitHub.
bar, in the top, in the bar. This home download, the third one.
Oh, okay. I'm sorry. Uh, it's not doing anything.
Cool.
Yeah, yeah, but oh, oh, science Q&A feature in the leaked Google document. This is yeah. Sorry, I'm sharing the GitHub. So they have the news here saying science Q&A feature in the leaked Google document. That's wild. Okay, but where do I data? So they have some captions. What? I mean, I think that we're just gonna assume that there are images, I guess, but Hugging Face.
Try to open also the
Yeah,
JSON
yeah, yeah.
file in
No.
the
Wait. It's on Hugging Face. Okay. Yeah. So they do have an image. Okay. Okay. So they have an image. So let me go back on the paper. Share your screen. Change window. Paper. So they have images. Okay. Well, I mean, that's it basically, I guess. Now, so what will be interesting is the blog post, right? Because I'm sorry, their website, because they say they have a new version, right? So what's changing? So here they say Llama 1.5 receives SOTA on 11 benchmark, 1 day on a single 8100 node. Oh, okay. There is the paper for the 1.5.
Okay.
Okay. So let me download that. And let me store it to disk. Let me share that. I need to open that bad boy. Why so complicated? Okay. Change window. Okay. And now I need to also, okay. Yeah, this is 5 October, 2 weeks ago. Okay, so I guess like we know the baseline, right? So I guess we can see what changes. Yeah, so what changes? What changed? Yeah. Yeah, so this seems to be the sort of, okay, improved baseline with visual instruction tuning. So I try to go fast here. So using multimodal models have recently shown encouraging progress with blah, blah, blah. In this note, we show that fully connected visual language cross-model connector, no wait. In this note, we show that the fully connected visual language cross-model connector in LLaVA, so what the fuck is this? The fully connected visual language cross-model connector. What is this? It seems wrong, right? So visual fully connected visual language, and
Can you zoom that graph?
yeah, here.
There is some what do you call this type of graph? What is the name of it?
I don't know. So what is his name? I just call it, I don't know, big dick plot, I guess. This is so if you need to do a plot like this one, it means that you're very smart. But here someone did something weird. Because there are two on the same one, basically. So 1.3 and 1.5. Yeah, so here you have all the data sets, basically. So do you want to speculate how they make it better? What do you think? So to me, I guess they have better data and better language model, and maybe I don't think so. Maybe they use GPT-4 Vision to actually annotate some new images or something like that. I don't know. It was still from Microsoft. It's still from Microsoft. So maybe they have it before.
Or maybe
Probably.
they use the sync attention, the new types of attention.
Yeah, like my educated guess would be Llama 2 minimum, more data, and maybe they had something. Maybe they changed the way they do the projection, right? So which was very vanilla, probably. So let's see. With simple modification to okay, so we still need to understand so what fully connected visual language cross-model connector is. With simple modification to LLaVA, namely using clip VAT large, okay, bigger clip, apparently. I mean, the difference is that it's trained on a bigger image, probably on more data as well, with a multi-layer perceptron projection, adding academic task-oriented visual Q&A data. With simple formatting prompts, we establish strong baselines that are state-of-the-art across 11 benchmarks. Our final 13 billion checkpoints use manually 1.2 million publicly available data and finish full training in one day on a single 8100 node. We hope this can make state-of-the-art large multimodal model research more accessible. Code and model will be publicly available. This abstract is a little weirdly written here. Okay, so let's go directly to what they did. Improved baseline of LLaVA.
Are you still? We see the first page.
Here?
Okay, are you still in the first page?
Do you wanna? No, I'm sorry, not following here.
No, we are seeing the first page of the PDF
You are seeing the
archive.
first page of the
Yes,
Oh, okay. So I share. Fuck.
I think that this is the wrong screen.
Yeah, I share the Brave tab, and not the. Yeah. Okay.
Yes, okay, cool.
Okay. So sorry. It happens all the time. All the time. Okay. So let's check quickly how they improve it. Overview. As initial work of visual instruction tuning, LLaVA showcase commendable proficiency in visual. Yeah, but this paper is written a little weird, like commentable. This really okay. Visual visual reasoning capabilities, surpassing even more recent models on diverse benchmark for real-life visual instruction following tasks, while only falling short on academic benchmark that typically requires short-form answer, e.g. single words. The latter was attributed to the fact that LLaVA has not been trained on large-scale data, as other approaches do. So this is BS because LLaVA is using Llama, which was trained on large-scale data, right? So yes. I don't understand. Is that there's from science Q&A, the benchmark for that one, it doesn't seem that you just have an answer that is yes or no, I guess. I mean, you have short answer, but they fine tuning on that one in the previous paper. So yeah, I don't understand here. So why they're making this claim. In this note, we first studied the scaling effect of data models and input image resolution on a selected free data set in table 1. Okay, so basically here, okay, so here they are saying this is the default one, right? We add this data set here, we are getting this, adding this, we are getting this, and the okay. And we show that the LLaVA architecture is powerful and that efficient for visual instruction tuning, and receives the best performance using significantly less compute and training data than all other methods. Response formatting prompts. We find that the inability to balance between short and long form VQ&A for approaches like instructor build is mainly due to the following reasons. So here they are basically say, hey, you know, it seems to be hard for, at least for this model, to decide when to use a long answer and when to use a short one. First, ambiguous prompts on the response format. For example, Q, question, A, answer. Such prompts do not clearly indicate the desirable output format and can overfit a large language model behaviorally to short form answer, even for natural visual conversation. Okay. I mean, it's, yeah, I mean, here, yeah, you don't, I don't know. Second, not fine-tuning the large language model. The first issue is worsened by instruction blip, only fine-tuning the Q-former from instruction tuning. It requires the Q-former vision output tokens to control the length of the large language model's output to be either long form or short form. Okay, so here I don't remember how the Q-former works. But I say it requires Q-former visual output tokens, which I guess are the tokens that are getting together with the text token to the language model to control the length of the large module output by either long form or short. Okay, here I have no idea, as in prefix tuning. But Q-former may lack the capability of proper doing so due to its limited capacity compared with a large language model like Llama. So if anybody here remembers how Q-former works, please say that, or we just take it from granted, because I don't think that we should check.
No, sorry, I don't remember.
Yeah, I don't remember that as well. But here basically is saying, because how the Q-former work, I think that in Q-former, that is from Blip2, you have the image encoder. You take the stuff from the image encoder, you put that in the Q-former. The Q-former also sees the text encoder, and then you shoot them in the language model, I guess. So probably, since the Q-former is in charge of doing all of that, is also in charge to understand how much tokens like are they assigned to the image and how much to the text, because like its output is going inside. I don't know, probably. Let's say to address it, we propose to use a single response formatting prompt that clearly indicates the output format to be appended at the end of each view Q&A question when promoting short answer. Okay, so they just add this at the end. Okay, that's it, basically. We empirically show that when large language model is fine-tuned with such prompts, LLaVA is able to properly adjust the output format according to the user instruction and does not require additional process of the VQ data using ChatGPT, which further enables scaling to various data sources. By merely including VQ V2, okay, in training, okay, so VQ V2 probably is this data set elevated. So they are saying visual Q&A. Okay, so they are just incorporate that. Okay, yeah, but so this is a difference. No, this is fine tuning. Okay, so they just incorporate this in a prompt during fine tuning, I guess. They're using Vicuna. Okay, so they switch from Llama to Vicuna, and that would be interesting to see something based on Llama 2. Yeah, it's let's see from then, like blip 2 is getting fucked, really, yeah, this is so much better. LLaVA, what is LLaVA? I don't know. All these data sets here, I don't know. LLaVA bench in the wild, yeah. I don't know about all these data sets here, but I don't know if you want to check them. Maybe the only interesting thing to check would be this VOK V2. Because it seems to be one of the key things making, yeah, so let's very quickly, like 10 minutes, try to check that paper very quickly to understand what's going on there, because they fine-tune on nice, okay, so they fine-tune on this one, right? This seems to improve that quite a bit. Okay, so let me share the tab with that paper very quickly. This one. Okay. And let's see. So elevating the role of image understanding visual question answering. So V is visual, right? So probably okay, so this is view Q&A. Then these are some weird images though. Is this kid fake? It's just me. I don't know. So let's see very quickly. So oh my god, I remember this computer. My mom, she had one of these. Damn. It's always funny to see this kind of data because it's always of old stuff, right? So this TV, that stuff, all these images, they look old. Okay, and sorry.
Yeah.
So let's see. So let's see if they are an example of what changes. So this is view Q&A. So probably no. Okay, so this is just the data set made of this stuff, right? Probably sample in a smart way. Okay, so they have, yeah. So they have kind of short answers, numerical one, a little bit more longer stuff, etc., etc. Okay, so it's just a data set that is made in this way. And then, so if we can go back to the paper, then I'm kind of wondering how they fine-tune on that one. So did they generate using their method, I guess? Okay, so they say, okay, so I guess they took the images, right? And then I guess that they construct the user query using the table that we see before, that, like, for example, so what is in the image, and then they create the assistant response, using the caption from the dataset that we just see. But in order to make it that makes sense, we add this sentence, before in the faked human prompt, because all the data here is basically just a single word or like a small sentence. Okay. 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 So looks like that they took the old one and they fine-tuned on that as well. Yeah. They fine-tune on that with a formal prompt, and then I guess that they change something else that we still have to see. So let's see the MLP. Okay, so I guess that there is a V2 of the paper that we just read. So the multi-layer perception visual language connector, inspired by the improvement performance in self-supervised learning by changing from a linear projection to an MLP, we find that, so they just changed the projection to, I guess, dense layer. Nice. And academic task-oriented data, we further include additional academic task-oriented VQ dataset, training more data. Furthermore, we find further adding regional level view QA dataset, ref coco. Okay, improves model capabilities on localizing fine-grained visual details. Okay, so more data. Additional scaling, we further scale up the input image resolution to allow large language model to clearly see the details of images. Okay. We also incorporate shared GPT data and scale up the large language model to 13 billion. So shared GPT. So what the hell? Okay. So shared GPT was the dump of users' conversation between chat GPT that basically was that people basically stole from OpenAI, and they were used and they're still available, even though it's like kind of illegal, and they are used them to create Vicuna. So it's not that they use them, they just use Vicuna instead, basically. And that's why we have Vicuna here, right? Yeah, so that's it. So now I'm kind of wondering, because like so this is kind of weird. So they basically add this data set, and this data set here, and this data set as well. And in the improve stuff, then they use a better model, which improves stuff. Bigger image encoder, improving stuff. So I'm kind of wondering, so what will happen if I do that, like with Mistral 7B Open Orca model? And maybe, I don't know. So that would be nice to try, I guess. And let's see. Okay, so this is nice. Please read the text in this image or to the information. Should we try to see if we are able to parse a table with the model? So if I so let me go back here. Okay, now I want to remove all this stuff. So let me try to find a table on Google, and let's see if we can get the them. I Googled for table, and I got a table. Table data. No, fuck. Data. Let's see. Can I? Okay, so let's see. It's because this is challenges because there are actually two tables. Right. So let's take this. Save image. Downloads. Okay. I have a table. And then please read the text in this table and return it in JSON form in this JSON format. Let's see. Header x6. So header, okay. Then we have rows. Oh wait, I just gonna say in CSV format. If this works. No. Okay. I thought it was a joke as well, but this is
Yeah.
yeah. I thought like, what the fuck is the model doing? And
Are you
okay.
kidding me?
Okay, so apparently I pick up the only table on the web with the lorem ipsum.
One double of content.
No, wait, it's hallucinating.
Sì, tu, yeah.
No, consider speech legit.
Sì.
It's hallucinating.
Yeah, not all of them match.
No, it's basically just continue the lorem ipsum blah blah blah
Yeah.
blah. Okay, so
Yes.
let's just wait for it, and then we can try.
So I read the first phrase and he thought that it was a lorem ipsum,
Yeah.
maybe.
Yeah, so like, this is always the problem with this model, and these papers, because like, for fuck's sake, how come that in two examples that we try, we got two hallucinations, right? So just
Yes.
tell me in the paper, we experienced some hallucinations. It's never ending.
No, it will end once the context means the full length is done. See,
Okay, 512. Okay, so let's try to
Maybe
say,
try to
are you
put
sure?
the temperature equal to 0.
Okay,
yeah, some decrease the temperature, then see maybe
yeah, but I think that if I
And top P also. And first decrease the maximum output tokens so that if gibberish comes, then we know that it will be gibberish in at temperature 0 sooner.
let's try. Uh, please
Maybe this is given by the
look
maximum
at the
output.
image.
Mm, no.
Should we try with GPT-4? And let's see.
Yes.
Okay, so let's.
I tried 2 days ago to extract the receipt, but it didn't work as well as.
Okay, I have a system prompt, which is kind of weird. So don't, yeah. It's gonna call me daddy.
That
Then it gave me it gave me the name of the columns, which makes
the
sense.
label. Yes, he created the label for the
Then this
issue.
is fucking incredible. I can't wait to have an API
Yes,
for that. It's gonna make my life at work so easy.
yes, it's a game changer for a lot of startups.
Okay, okay. Yeah, but you know, it's not like this table is hard to read actually. It's pretty
No,
readable, right? So so here I guess the issue still is
yeah.
that they haven't trained on too much data, I guess. Because I don't understand like what it was, yeah. I don't understand like how this can happen. This is really hilarious, yeah. Read the table and returning. So let's try again with a lower temperature. Okay.
The
So
crazy thing that is that it has been presented as the best architecture, so the SOTA, but compared with the GPT-4 is a shit.
yeah, but you know, the issue, I mean, the main issue, man, is that the benchmark that they use, they do not really mimic this kind of stuff that we do. They're more, yeah. So it's hard for them as well to evaluate them, but I don't understand. Like, if I just playing with this, it's not working. So what I'm gonna try to do, so since they fine tuning on scientific stuff, I'm gonna take a latex table, and we will see if we're able to get some data out of that. So let me take, okay, save images, web piece, let's see, clear it. So we have table, oops, like how hard can it be? Well, this is really incredible. This is really hallucinating a lot. So let's take an
Mm,
image.
I think it reads the fourth element for each row and each column
One, two.
because 1, 2, 3, 4, cell 4 it doesn't exist, but the other ones
Yeah, but
exist.
still, like here, the formatting is wrong.
Yes, it's a wrong output,
So let's
I
try
believe.
to take an image that has some sort of text, but is cut in the middle. So let me just try to find, I don't know, text sign, and I will cut it in the middle. Let's see. Okay. So let me second. How do I screenshot in Ubuntu? Damn, I don't remember. What was F3? Damn. Wait, screenshot. Okay. Then yeah, and then like, what do I? Uh, okay, no, wait. I'm trying to understand how to do a screenshot on a fuck. How to do a screenshot on Ubuntu, and store it on my desktop. But okay. So let's try with more memes. Let's see. Feel free to find memes. I mean, to send memes on the chat as well. So let's try to see something of this one.
But
And this is so I need to, okay, I can go here and I can go see all.
but is it possible that it has this kind of meme in the dataset that has been used to train it?
No,
And this
no,
is the reason why it is able to understand that it is a meme? Or
I don't think it's so good at understanding. So let's try this one, and this is actually cool because the standard addiction is for the hardcore fans. Um, so let's try to put this one and explain why this image is funny.
we see the old screen.
Okay, thanks.
Okay. Try to remove the text and give only this image, and in order to try to understand if it
Yeah, but
classified as meme, even if it is not the text.
yeah, but I mean, you see here, it doesn't make any sense. In one scene, there is a cartoon character of Winnie the Pooh, who is a well-known and
Right.
beloved character from Schindler, blah blah blah. In the other scene, there is a reference to the Lord of the Ring. This is not true. So let's see. Are you sure? Let's see.
Every time I
No,
apologize.
no. I realize this is not funny. No, this is gold. This is really gold. So I want to take a screenshot, but I need to make this bigger. So can I make this bigger? If I do like hide 2000 pixel. No, it's this one inside.
I was also trying with this to put in like random images of food and try to get like calories and macros from it.
Yeah.
Even that it does like it gives like non-consistent weird answers. Like, it's like uncertain, like this, like it's just
Yeah,
spitting out info,
just
no.
I need to take. I want to take this as a screenshot because I think it's very funny. That it's basically say it's not funny.
Yeah.
Okay, so let me very quickly save the image. Okay. Okay, so let's yeah. So let's find uh, Big Mac. Okay. Let's do clear. Can you give me an estimation of the calories in this food?
We are in the old screen again.
Oh, thank you.
Okay.
Yeah.
Yeah, but
Okay.
you see how the model was trained to describe an image, right? Like the sandwich
Yeah.
appear to be so this is really like the pre-train on describing an image, right?
Yes.
Okay. So let's try with GPT-4. So this is the typical burger patty can contain. Yeah, it makes sense. Yeah. So this is well done. So let's try to do the same thing with GPT-4. Yes, daddy. Very similar. Yeah, it's true.
Okay.
More accurate.
Yeah, I mean, of course, it's a huge. I mean, you can't really do a
Yes.
comparison, right?
Yes. And in Lava, we also have the 100 token maximum size.
Yeah. Like, yeah. Uh, Damn, it's so funny because I prompted in a way that every time he has to do a Star Wars joke, and it's every time it's different, and every time it's funny. Now it's also putting an emoji, like yeah,
It's fun to work with this kind of technologies.
yeah. Okay. Um, okay. This is this is good. Should we try another meme, and then we call it a day? Um, where is uh, where is memes creator? So let's try to. They have non-safe for work memes. Okay. Uh, okay, so let's try to find the ones for this one. Okay, so let's use this. Let's see. I think I need to hit clear. Clear. Why is this not funny? So let's see. This time we try. The image is not funny because it is a meme that uses a stereotype. Okay.
Yes.
Huh.
Okay. Yeah. I mean, so this makes sense because it doesn't know about the ongoing wars. Okay. Yeah. So let's put a little bit more tokens. So, yeah, here it has its ridiculous bias in censorship. Um, so, uh, what what if Israel Israel was a man? So let's see. If Israel was a man, the meme would still be offensive. Nice. So the next questions, and we were going to test the um, how do you say, the censorship or the human alignment, how's they call it, and yeah, blah 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 blah, right? So are you saying that having Israel written on you is offensive? Let's see. Okay. So here we are basically, so we are chatting with Vicuna, basically. Um, Okay. This seems to work well. I'm kind of wondering if there were this type of memes in the dataset, as you were saying, uh, is there a specific meme that is very new, like the super new meme, fun, cats? Okay, so let's try. So let's try this, which is pretty terrible meme, but I never seen it because probably it's terrible. Um, okay. Oh, what is funny? It is meme. Funny aspect of the image is that the woman is trying to get a cat involved in the situation, but the cat is not cooperating. The cat is sitting on the wall is not true, it's sitting on the woman's hand. Okay, okay, I mean it's okay. So I haven't really seen the breakthrough that I was looking for, right? Because in the way I saw people posting on LinkedIn, uh, it seems super good, but it's still, I think that they need to train on more data and better data. Uh, yeah.
Yes, it is not reliable to be used in production.
No, maybe super. So has a last test. Has a last test. So let me. There are people using that.
Maybe for like really constricted use case, you just describe the image or something.
Yes.
Yeah. So what if I'm going to? Damn, why it's taking so long to just clear it? Okay. If I take this image back and I say um, extract key information and return JSON static information from the image and return a JSON. So let's see. So what it's doing now? We are in queue. Okay. They are saying there is
Okay, it
a
seems
couch. So okay. So again, this is too much hallucination. Here is saying the scene is set in a room with a couch in the background. There is no couch. I do believe that they have data set with wrong captions, right? Yeah,
yeah,
this
could
is
be
100%.
possible.
This is 100% hallucination. So on which data was the original model trained? On Coco and caption? Sorry. So if I very quickly, so let me.
Try to ask it where is the couch.
Nice. Where is the couch?
It is exploding.
It's giving up on us. By the way, this demo is pretty cool. It's pretty cool.
Yes.
Oh yeah, the return to in JSON trick is quite good.
No, it
Many
isn't.
times it introduces consistency.
Oh, maybe the right part.
No, no, no. I check. It's something else.
Okay.
Okay. Now, if I say sorry, my my mistake. I see it.
No problem.
Oh,
What color is the couch?
Maybe it's thinking that that is the
Yeah,
couch.
maybe
Where
it has classified the
exactly
part.
is the couch? Yeah, like 336 pixel is just no, no, no,
Try
no.
to
It's
ask him if he's in the right or left part of the image.
so.
Yes, I think
Just
that
have a
it
position. Is
has
it in?
classified the right part as a couch.
Is it on the right or the left? Behind the woman.
Yeah, behind.
There is a door behind the woman.
Okay.
Okay, so where is the couch? What is going on here? This is so confusing. Oh my god. Okay, well, it's yeah,
Yes.
it is what it is. But it would be worth checking the train data that they created, because I do believe that we will find some hallucination there. And if we go on the code, sorry, can we see the data set? Blah, 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 blah. Okay, so they actually have done reinforcement learning with human in the loop. Okay, I mean they are working a lot of that, a lot of work. So let's look at the data set. But we want to see the images, right? Um, yeah, we can't really see. We need to download the images though. Damn. Or I don't know. So let me share this. What is this? Okay, it's a JSON file. This is a big ass JSON file that is gonna blow up my computer. Image. No, 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 no. Wait a second. So this is the dataset. We have an image, and the image is coming. The image is coming from. This is bleep lion. Oh, they use bleep. No, no, no. Okay, so this is why is that every paper that does use something to caption and create an image text pair, uh, it's gonna fucking destroy it. Yeah, so Chrome just crashed because the file was too big. So let me open Visual Code. So can you hear me?
Yes.
Okay. Visual Studio Code here. Yeah. So okay, so let's try to find these images though. In the data set, I need to lion data set. So let's see if we can find it on Hugging Face and see the ID. Lion face. If I look, oh damn. Well, but you can actually see here, right? So here we have human, render and clear concise summary of the photo.
Bye, Mr. Robot.
Bye, Mr. Robot. Have a nice one. Is Mr. Robot go?
Right.
Is it
Enjoy.
going? No.
Yes.
All right, guys. It was good exploring with you guys. I'll be
Bye,
leaving as
man.
well.
Have a nice one.
Bye.
Yeah,
Nice one.
yeah.
Have a
First
good
one,
day.
and looking forward to the next ones.
Yeah.
Yeah.
Super.
Bye.
Thank you so much.
It was a pleasure. Bye.
Okay. Okay, so yeah, the issue is that I don't know where to get this data actually, because it would be very nice to actually see the data, right? So I'm trying to look for that. Yeah, I don't know. Well, I mean, no worries, but we did experience some pretty heavy hallucination as well. And to me, this is because if you train on a data which you have used an inferior model to annotate the images, right? You cannot really expect your model to describe the image better than that model, basically, right? Because
Yes.
you are training on text that is generated on that model.
Yes.
Yeah, yeah. So we should check. Yeah. Well, I think that we can call it a day. Uh, it's really good. It's really good. Thank you so much. And yeah, I'll see you on the next one. I'm gonna put the video, I don't know, in the weekend on YouTube.
Yes. Yes. Thank you,
Thank you so
Fra.
much. Ciao. Bye guys.
Alla
Ciao.
prossima.
Bye. Alla
Bye.
prossima.
Ciao.
Bye.
Ma Delax, sei italiano? No.
No. Bye.
Delax from?
Yeah,
Where are you from?
no, I'm from Nigeria.
Oh man,
Okay.
that's a long way from. Yeah, I mean, damn.
Yes, it is.
Are you on the same time zone as we are, right? I guess because it goes. Yeah, like it should be more or less on
No,
the same one, right?
it's about 1 hour. There's a 1 hour difference.
That's crazy.
Yes.
So yeah,
Yes.
That's
I guess
crazy.
this is the power of the internet.
No, yeah, I mean it's crazy that like you are so far away, but we're still on the same time zone, and we are kind of here on Discord reading papers. So that's really cool.
Yes.
Yeah, I tag you on the text channel because I usually, then I just put the recording on YouTube, and then usually I make a LinkedIn post saying, we had we read a paper together, and since I think this is the first time that you are with us, I just say in the text channel that if you can give me your LinkedIn name, and if you want, I can tag you on the post.
Yeah, sounds awesome.
Super.
Yeah, we'll do that.
Yeah, feel free to DM me that. Thank you so much again, and see you on the next one. Bye.
Thank
Yeah.
you. See
Bye.
you.
Ciao, guys.
Have a
Bye.
good weekend. Bye.
Have a good one as well. Ciao.
Bye.